מודלים. רון הוא השף של בריה, כשזה מגיע למודלים, Director of Research, והוא הולך לדבר על, על Exploring the Intermediate Language of Visual GenAI.
Hey. Okay, so I think I will speak in English, so this will be able to be recorded. So excuse me for my English, but I think we'll be all right. Yeah, so for those who are not familiar, I'm Ron, leading the research at Bria AI. And today we'll talk about unboxing image generation models. And at this point, I'm sure everyone is familiar with image generation models, but one question that bothered me for a long time is that how image generation models reason. Like, how can we control and understand the reasoning process of these models? And text-to-image started as a black box, like we have user prompt, we bring it to the diffusion model, we get an image. And we had no idea why the model put an object in a specific place, specific size, specific color, if it's not specified. And like over the time there was like, I think, and I'm not exaggerating, like hundreds of work, like using the attention mechanism, which is pretty effective in some cases, but definitely not robust and quite complicated. But what if we have a much more easier way to really control this type of models? And today I present a new paradigm, like instead of a single step, we actually use two different models, one for reasoning and one for rendering. So the reasoning model translates the user input into an intermediate language. And then we use this representation and bring it to the renderer to generate the image. And it gives us the ability both like understanding better like how the reasoning is working and also control the generation post-reasoning. And this is what I will demonstrate in this talk. And I will show it by show like various projects. We'll start with Fibo Edit, my favorite Fibo Barbecue, and a sneak peek to Fibo Fast. Okay? And we start from text to image, and we're asking ourselves, like, what was the pain that we try to solve with Fibo for image generation? And we've noticed, we've seen that many users, especially like creative experts, professional users, like they want to generate an image and they have a very clear vision of what they want to generate. And they want to control like different aspects of the image, but when they use like a very standard model, they get like image which looks like good, maybe excellent, but this is not what they had in mind. And this is because like the representation of images is very rich, very dense representation with a lot of details. Like image is worth 1,000 words. And like short descriptions are sparse representations. So basically when the models are trained from sparse representation to dense representation, they become creatures which are hard to control. And for this purpose, we've trained Fibo. And Fibo is the first open model which is capable of generating an image from 1,000 words. And it was trained exclusively on long structured captions. So it means that during training, each caption, each image is described exactly in a structured way. And we put this emphasis on professional control for the model. And indeed, as you can see here, or with other example, it results in a new level of control as the model learns now to map like highly detailed captions to highly detailed images. And here you can see example of such long structured prompt, and really it's so long I couldn't fit it in one slide, so I have to take a video. And because it is structured, we also get something really, really nice, which is native disentanglement. And this model was not trained for editing, like we haven't trained it even with a single pair of images. But when you change specific part of the structured caption, only specific part of the image is changed. So we can start with this image on the left, and by just generating specific part of the JSON, we can change the text on the bottom, we can change the season, and we can do many refined operations. And there is no even degradation because we only change the caption. We haven't worked on in the image space. So this is a nice thing. But the challenge is, obviously, no one can write like 1,000 words prompts. This would be very difficult and tedious. So we use a VLM to translate the user intent and to fill up missing details. And this actually gives more power to the model because now our VLM has more word knowledge, reasoning, and much easier for integration. And why we need the V in the VLM? Because we can also use images as inspiration. And this is a benchmark from where we released the model, which was in October. And we can see that compares to models in the same size, open models, we achieve much better prompt alignment. And the model is open, so you can scan the QR code, play in our free demo, and experience how it is to generate images with long structured captions, which is fun, refine them. And also, we released a technical paper, so you can see all the necessary details of training, etc. So, to summarize Fibo, because we split the generation process into 2 steps, we achieved a renderer which is much more controlled and accurate. And we can also use much stronger reasoners. For example, we can use GenAI as a reasoner if we want to take it to the extreme. And naturally, this brings us to Fibo Edit, because obviously we can take this model and now tune it to edit real images, which is a natural steps. And indeed, it was very exciting to launch Fibo Edit like 2 weeks ago, and this model is also open source. And we use the same paradigm, so we start with the reasoner, and the reasoner gets both the editing instruction and the input image, and translate it to a structured prompt, obviously. So this prompt describes the edited image, the output images, and it fed to the renderer together with the input image. So using the same paradigm now for image editing. And obviously there are many editing models out there, but what's nice here is that we can understand the reasoning of these models. So I will show an example, which I like. And the edit here is to replace the baby on the left with a cat and also delete the people at the background. And we get a pretty decent result. But there is like a wooden spoon there, which is like floating in the air. And we can just visit again the JSON to understand like why the spoon is there. So indeed, we see that the reasoner just left there as one of the objects. So we can obviously delete it and get like a nice edited image. But what's nice here is we can also now teach the reasoner we can ask the reasoner to avoid like keeping floating objects. So it is much easier to understand the reasoning process of this image editor. And we are in the arena, obviously, and I'm very proud of this model because it's competitive to other models, great models in the same size, like QuenEdit Flux Context with only 8 billion parameters. And of course, FiboEdit is fine-tunable. So we actually fine-tune it to remove background. And we hope to release this model soon as well, which will continue our very successful line of background removal models. And again, this model is fully open on Hugging Face. You can take it for a ride. And okay, one last edit example, which I really like, is that we fine-tune it. Okay, I will do it again. Okay, so we fine-tune it to change camera angle, and we use data was created by our friend Lovis from FAL. He used the Gaussian splatting, this is synthetic dataset, and the UI by Polly from Hugging Face. And I really like it because it creates a new experience. Like, this is no longer like a text to image, right? You don't use text. You can use a new UI. And I really liked it. And it brings us to the next topic, which is my favorite, and is Fibo Barbecue. So how can we take this type of models like one step further? And we believe that we can add more parameters to the structured captions. And in Fibo Barbecue, we show that these parameters don't have to be text. So we add numeric bounding boxes and numeric colors like X values or RGB values. And this is now part of the intermediate language of the model. And this is nice because we can build really nice UIs around it. Like here I move the duck and I increase its size. I can change the color of the float. And what's happening like behind the scene is that the structured caption is changed to these specific values, and we get generated images that match this description. And I will show another one. Again, I can take the duck, move it, move the ball around, change the color of the glass. And the only thing happened here is that we just added these numeric parameters to the structured captions and trained the model with it. And indeed, the object get the correct size, location, and color. And I really like this direction because this research will enable us to move like beyond just text. Like we can move to new user experiences, and you can only think about like which new parameters we can now incorporate in these models. And I'm almost done, but before I will first want to thank Moonmat people for organizing this great event and hosting me. And I will manage this opportunity to talk about Fibo Fast, which is a collaboration between Bria and Moonmat together. And basically, the goal of Fibo Fast is clear. We want to make Fibo fast, right? And it's not easy because the reasoner can take more than 10 seconds, and the renderer can also take more than 10 seconds, which is a lot. So we started from improving algorithmic aspects. So we first, instead of using like a very big reasoner, we fine-tune a small one, like 4B VLM, and we get significant improvement. And for the diffusion model, we perform both CFG distillation and SCFM to move from 100 to 8 NFVs. So in this algorithmic approach, we get already significant improvement. And next, the Mugma team took it one step further, optimizing at a lower level of the stack. And basically they reached 1.6 seconds for the reasoner and 0.7 seconds for the renderer. And I think we will get it even lower. And this gives a much better experience, as now it takes like less than 3 seconds. In this video there is a small overhead, but we are working on this. So this is a nice collaboration. And obviously, I know what you're thinking yourself, like, okay, we have like great editing models out there, right? We have Nano Banana. But Nano Banana is closed, and these models are open. So we can study them, we can fine-tune them, we can put them as part of our pipeline, we can deploy them in our infrastructure. And we do believe that for developers, it's much easier and more effective to work with open models. So I hope you will give them a try and enjoy them. And thank you.